Okay, guys, so here's the rest of the cycle B quest. All right, so you're given that f is continuous on this closed interval, -10 to 4, in the table of values below. Use the intermediate value theorem to explain why there exists a value c between -10 and 4, for which f of c is 2. So here's a little visual. And guys, you really want to go back and look. If you go to our Google Classroom, there is a huge document that I compiled at the very beginning of this, which was everything we had done all year, all the answer keys, all the everything. And I was just scrolling back through that to remind myself how I taught this. And it was I know it was a long time ago. I don't even remember back then, but in looking back, it was developed very well. So I'm not going to try to reinvent the wheel here that I already invented back then. Just take a look. If this doesn't speak to you what I'm about to do, go back and look at that. And then also, guys, if you feel like I'd rather focus on other things in the intermediate value theorem, by all means do that, Okay, so anyway, I took this table. This is not totally necessary, but I took this table just for a visual. I put it down here. Now, the fact that this function is continuous allows me to connect these dots, okay? And it might look different, like between any two dots, it might look like a lot different. But anyway, just knowing continuity, I can connect these dots, and I'll just do it in the most simple way possible. Now, it's asking me to use the theorem to explain why there exists a number c between -10 and 4, for which f of c is 2. Well, here's the y value 2. So, guys, right here, at this point on the graph, I have a y value of 2. All right, so that's where my c is. It's right there. So there's a picture, but now let me explain this. So I'm going to say this. I'm going to say, I'm going to say that f of -10 equals 0. Okay, so I'm taking the endpoints and figuring out their y values. So f of -10 equals 0. F of 4 equals 7. And 2 is an intermediate value, meaning that 2 is between the, this number 2 is between the outputs of the endpoints of this function. All right, now, so here I've established the intermediate part. Now I need the continuity part. So since f is continuous on -10 to 4, by the IVT, the intermediate value theorem, there must exist a value c where -10 is less than c is less than 4. So now I'm just copying this basically. A value c for which f of c equals 2. For which f of c equals 2. All right, so there it is. Now, for the same function f as number 8 above, use the intermediate value theorem to explain why there exists an n between -1 and 3, for which f of n is -5. Okay, so guys, I need to establish that -5 is an intermediate value for those outputs. All right, that's the first thing I need to establish. And if you look at my picture, so basically I want to prove that on this interval here, there is an n for which f of n equals -5. And the way I drew it, it looks like it's happening right at 0. But that's just how I drew it. All right, so I'm just going to mimic above. So f of -1 is -8. I'm getting it from the table. F of 3 is -1. And -5 is an intermediate value. Okay, now I have to say, I want to be able to say, since f is continuous on -1 to 3, that's what I want to say, but I was not told that at the beginning. At the beginning, I was only given that f is continuous on this, -10 to 4. But if f is continuous on -10 to 4, guys, then it's got to be continuous on any subinterval of that. Okay, so I've just got to establish that. So I'm going to say, since f is continuous on -10 to 4, it is also continuous on -1 to 3. So there I have it. That's what I needed. I needed this -5 to be an intermediate value, and I needed f to be continuous on this closed interval. Okay, since f is continuous on that, is also continuous on that. Okay, and then I'll be like, therefore, by the IVT, there exists a value n for which fn is -5. Okay, so there it is.